Alright, okay, let's go for this function, a second video that I'm talking about relative local maximum and minimum point. So I'm going to show you the first derivative test, okay, to identify the relative maximum point. So I'm going to show you how to using first derivative test and second derivative test on the same video. So very simple. Of course, every time when you want to find a critical point, okay, a critical point for these cases, either they're setting critical point or relative local maximum and minimum point, is always referred to stationary point for polynomial. All right, so you will need to find f prime x equals to 0, right? So of course, firstly you differentiate. You have 4x to the power of 3, 4x to the power of 3 minus with 2, 8, 16x, right? You have 4x cubed minus 16x. So then you equate this equals to 0, as you want to find the critical point or the relative extremum point or the local extremum point. So it's all bring the same meaning here. So equal to 0. Divide everything by 4, or I can factorize the 4x and I have x power of 2 minus with 4 equals to 0, right? So you have 4x cubed for 16x. So you have x to be 0, as it's possible to be 4x 0, or either x squared minus 4 equals to 0. So if you're solving this, you are getting x 0, x equals to negative 2, and x equals to 2. Can you see that? There are 3 stationary point, okay? 1, 2, 3, 3 stationary point. So it means that we have to do the test for each of these point, right? Each of these point. So before that, we have to find the value of y, right? We have to find the value of y for this case here. So then we're going to say when x 0, what is your value of y, right? So when x is negative 2, what is your value of y, right? The coordinates of the stationary point. So x equals to 2. So y equals to, so what is the value of y? So you can using calculator and find. Alright, so as you substitute the value into the x0, you substitute the value into the fx here, which is also represent the y value, okay? The y value. So you can find the value of y here. So you calculate 0, you are getting 16, right? 16, so means you're getting the point of 0 and 16. And negative 2, if you key in negative 2, then you are getting 0. You're getting 0. If you calculate 2, you are still getting 0. So means you have 3 coordinates. Negative 2, 0, negative 2 with 0, 2 with 0. Okay, I get the value of y by substitute the x value into the function here to getting the value of y. So I have 3 points. But I don't know, these 3 coordinate here, which one is a relative maximum and which one is the relative minimum. So we need a test, okay? I'm going to show you the test, the first derivative test and the second derivative test. Alright, let's go with first derivative test. First derivative test, you have to see how many points, 0, negative 2 and 2, right? This is all the stationary point. During this point, the dy dx all 0, right? The dy dx, the f prime x all equals to 0. So means the tangent at this point is horizontal, right? Horizontal, either is a relative maximum or is a relative minimum, right? So we have to identify. So how to identify this? Very easy. So we just draw an interval, we just do some tests. There are 3 points. The lowest point will be negative 2, the smallest negative 2, followed by 0, followed by 2, right? Followed by 2. So we construct a table, So with 3 columns, 1, 2, 3. So the first one will be represent the interval of x, right? Which we divide it into 4 intervals, right? 3 points. So right, left, right, left, right, left, right. So there are 4 intervals here. So this, the first one will be negative infinity up to negative 2, which is less than negative 2. And this is between negative 2 and 0. Between negative 2 and 0. and this is a value between 0 and 2, right? 0 and 2 and beyond, 2 and beyond, 2 to infinity. So alright, then I'm going to erase this now and I'm putting here as negative 2. This is 0 and this is 2, right? So I build a table. Okay, so this is the sign of f prime x or dy dx, right? Sign of f prime x, positive. The meaning here is positive or negative. And the shape of tangent. Shape of tangent. Very important, the shape of tangent here to identify the relative maximum and minimum. So now, since this is a first derivative test, right? First derivative test. So means we are using first derivative. This is the first derivative here, right? This is the first derivative test here. So very easy. So for me, I will always using my calculator. I will key in this 4x cubed minus 16x. All right, 4 alphabet, right? So it's easy for me. 4 alphabet x shift cube, right? Minus with 16 alphabet x. So I have my function here, my first derivative function, right? My first derivative function, 4x cubed minus 16x. Then I'm pressing the button calculate, right? Calculate. Okay. So now look at the 4 interval here. It's less than negative 2. Choose a number. Pilih satu nombor yang kurang daripada negative 2. Choose a number less than negative 2. I will choose negative 3. Okay. So you will key in negative 3 and pressing double equal. You will get a negative. The number is not important. We just want the sign. Okay. So we have test. The sign here is negative, right? Then we go for calculate again. Calculate again. Now go for between negative 2 and 0. Di antara negative 2 dengan kosong. So what is the number? 0.1, negative 1, right? Negative 1.5, any number in between here. So we test the value. We key in negative 1, right? In between. So negative 1 equal again. I get a positive sign. 12, right? Positive. So I will put in here positive. So now go for this. Between 0 and 2, right? 0 and 2. So you calculate 0 and 2, you're choosing 1, right? 1, then you double equal, then you're getting a negative number, right? You're getting a negative number. It is not always alternate. Don't assume that if negative, positive, negative, here will be positive. No, sometimes it's not happen in this way. Okay. So calculate. Okay, more than 2. You can calculate for 3, 100, anything. Okay, calculate for 3. Just pressing 3 equal. Then you have 60 positive, right? Positive. In this case, yes, there's a net alternate, but not all the cases here. Be careful. So negative, the shape of tangent will be this way, right? All the straight line that have gradient, f prime x is a gradient. It's a gradient of a tangent, right? If negative, the gradient will be looked at this way. Positive this way, negative this way, positive this way. With the shape here, with the shape of tangent, we can identify negative 2, negative 2, right? Negative 2, negative infinity, negative 2 to 0. So there is a change of sign. If you draw complete, can you see? This is a minimum graph, all right? Where if you join them, this is a dy dx. So along this line, negative 2, 0 is a stationary point. The dy dx is 0, right? So if you see that, this is a minimum point. So how about 0? If you draw, it's a maximum point, right? It's a maximum point. So it's a maximum point. And if you connect this, you are getting a minimum point. Means there are 2 minimum point, one maximum point. Which negative 2 and 2 is a relative minimum point. Negative 2, 0. Negative 2 is negative 2, 0. And 2, 0 are the relative, or sometimes the books using the term local, right? relative minimum point. Okay, do a statement here. Alright, so and 0, right? If you test 0, before 0, after 0 is negative, positive. So you look at the graph here. It will be 0, 16 is a relative maximum point, right? Relative maximum points. Alright, so then you know that this is your minimum and this is your relative maximum point. Alright, so I have shown you how to using the first derivative test. Okay, so how about second derivative test? Alright, second derivative test. Okay, let's see how I do second derivative test. Alright, so the question is either require you to answer using the first derivative test or second derivative test, either these two tests. Alright, so okay, now I show you the second derivative test. Okay, the using of the second derivative test. Derivative test. Alright, so what is the second derivative test? Of course, just now your f prime x, your first derivative is 4x cubed minus with 16x. Okay, now go for second derivative because you want to do second derivative test. So which is you derive second time. So you are getting 12x to the power of 2, right? Minus with 16. So this is our target now. So if the sign of f double prime or d2y dx2 is less than 0, this is show is a relative maximum point. If f double prime, the sign of f double prime x is positive, then we say that is a relative minimum point. So if the sign of f prime x doesn't show is positive or negative, but showing you 0, neutral, so this means that the test is failed. The test is failed because you cannot identify its maximum or minimum. So you have to proceed. You have to do inspection method by using first derivative test, right? First derivative test. So first derivative test. So this is only when the test is failed. So now go for second derivative test here. So there are 3 points just now. You have x equals to negative 2, x equals to 2, and x equals to 0, right? These 3 points here. So we check. So when x is negative 2, right? So you have f double prime negative 2. You're putting the value into the second derivative. So then you have 12 negative 2 square minus 16. If you calculate this, you are getting a positive number. You will know that this is 48, right? 48 minus 16, positive, right? So when x is 2, you're putting 2. So you are getting 12, 2 square minus 16. 4 times 12, 48 minus 16 is still positive, right? Positive. Positive show what? If positive, first, second, and third. So if positive means that it's a relative minimum point. That's why you see negative 2 and 2 is a other relative minimum point. So how about when x is 0, right? When x is 0, so you substitute into the second derivative to do the test. So you substitute 0. 12 times with 0 square negative 16. This one you're getting 0. You are getting negative 16, which is less than 0, right? Less than 0 is a relative maximum point. Can you see that? It's a relative maximum point. Okay, it seems like this test and this test is much more easier compared to this. And then you will try to say, oh sir, I just want to learn this method. I don't want to learn about this. No. In calculus, you have to learn both. Actually, this one tell you the shape of the pattern is much more, you can see what is happening during that point, okay? You can go for more detail by using first derivative test compared to second derivative test. But this is an advantage for you because it's easier, right? You're just looking the changing of sign. So then I want to show you how to sketching the graph of this type of this function, a quartic function. Quartic, okay, is a power of 4 function. Okay, let's see. Alright, okay, let's look at the graph here. Okay, the extra knowledge for you. So y and x. Of course, you're learning all this because of graphing, right? Graphing. So if you look at this, put all the point, right? Negative 2, 0. Okay, negative 2, 0 is a x-intercept. 2, 0 also a x-intercept, right? So, and 0, 16 will be the y-intercept, 0, right? Okay, the x is 0. So 16, okay, 0, 16, somewhere here. So, you have these 3 points, then you, for sure now, you can draw the graph very easily. First, this 2 is a minimum point, right? It's a minimum point. This 2 is a minimum point, and this is a relative maximum point. So 0, 16 is a maximum point. Maximum point will be looking like this way, right? So the relative maximum point, right? Relative maximum point. And this will be your relative minimum point. Means that the graph going down and here is turned up, right? It's a turning point. So this is a stationary point, and this is also a stationary point, dy dx 0, dy dx 0 here. So of course here also the same, it will be going down and stationary for a while and going up again, right? And going up again. So this will be the curve. Alright, now this will be the curve. So this is a minimum, maximum. Alright, so according to this is a relative maximum, relative minimum point, and this is a relative maximum point. So the graph will be going this way. Okay, so this is how we study the concept of relative maximum and minimum in these cases here. Okay, see you in the next video.